Hello, and welcome to UPL Insights, the new digital media series from UPL, led by our friends and experts across the African continent. This series will bring together leaders in sustainable farming, food systems, and climate resilience to explore the challenges and developments defining world agriculture today. We are recording this episode ahead of the African Green Revolution Forum, the biggest annual agriculture event for Africa, which is now marking 20 years of AGRA's mission to transform agriculture. This year, the AGRF Summit is a virtual event, and we have been talking to some of the people leading that transformation inside and outside of UPL, and exploring our shared commitment to resilience, trade, nourishment, and sustainable productivity. My name is Florent Claire, and joining me today is Jane Camo, Commercialization and Agribusiness Manager at IITA, the International Institute of Tropical Agriculture, and Dr. Titilayo Falade, Associate Scientist at IITA as well. In this episode, we will explore one of the most challenging threats currently facing food crops and livestock across the African continent. The threat of aflatoxins and the risk that contaminated food products pose to the health of human and livestock is a growing problem in Africa, but very rarely gets the sort of attention that locusts, climate change, or water scarcity commands. So, what are aflatoxins? The short answer is that they're poisonous substance produced by a type of mold or fungus that is found naturally all over the world. In high quantities, this poison can cause cancer, birth defects, and weaken immune system in humans, and cause a variety of health effects in animals. And under the high temperatures and high humidity typical in many parts of Africa, these molds multiply at a rapid rate, invading food crops, livestock, and animal products. The danger that aflatoxins pose is so severe that at least 25% of the world's food crop have to be destroyed every year. This year's AGRF Global Summit is looking at resilience and food security for smallholders across the African continent. Food losses and waste forms a central part of food security, so efforts to combat perennial threats like aflatoxins are needed more urgently than ever. One of the most promising answers to this challenge is called Aflacife. Developed by IITA, it is the first all-natural crop protection product designed to combat aflatoxin, cutting toxin levels in maize and groundnuts by 80 to 100%. So, Jane Camo, to begin with, I would like you to talk about the history of aflatoxin on the African continent and maybe tell us why it has been called the silent killer.
Thank you, Florent, for the question. And the history of aflatoxin in the African continent is as old as humankind. And mainly because aflatoxins are caused by a fungus, and this fungus is resident in the soils and other naturally occurring materials. Why is it called a silent killer? Just like you alluded earlier on, aflatoxin has not received much attention. Why? Related to the fact that it's a silent killer is the fact that the toxins themselves are invisible to the eye. They cannot be seen. They cannot be tested. Until you have a laboratory analysis, it is difficult just to tell from your naked eye that this food is contaminated or not. And that makes them a truly invisible, silent killer. And especially considering in Africa, where most of our staple diets are predominantly maize, sorghum, and in a few places groundnut paste, then that tells you that most communities could be unknowingly consuming food that is contaminated. Thank you.
Thank you, Jane. Dr. Falade, can you explain us in scientific terms what is the cause and origination of aflatoxin?
Aflatoxins are fungal poisons caused by toxigenic strains of the Aspergillus species. And Aspergillus flavus is the most common. When the fungi infect the crops, they produce aflatoxins as secondary metabolites that then accumulate in the crop. So that's how aflatoxins get to enter the crop. And when they are consumed by humans or animals, then there is dietary exposure to aflatoxins, and then they cause a disease called aflatoxicosis in animals and humans.
Right. And can you elaborate a bit more on the effects of this disease exactly? What are the effects on human health and also on animal health?
Aflatoxins have direct and indirect effects on the health of humans and animals. There's a direct relationship established between chronic exposure to aflatoxins through the diet and liver cancer. And in animals, aflatoxins result in reduced quality of animal products, including milk, eggs, the live weight of the animal, and is associated with reduced immunity, meaning that the animals succumb to diseases more often than they would if they were healthy. Aflatoxins also negatively impact the feed conversion ratio of the animals, and this means that there is more feed required for the animals to get to the desired weight. In addition, there's reduced immunity in humans and animals, and this is very important, especially now with the COVID-19 pandemic, because it means that the ability for the body to fight the diseases is reduced. And so individuals with aflatoxicosis who are exposed to aflatoxins through dietary means are not able to fight diseases like COVID-19 and malaria and other diseases. And there's also stunted growth with children that is associated with aflatoxins. So these are some of the negative health effects that aflatoxins have on humans and animals.
Very serious effects indeed. Can you explain us a bit now, how does this aflatoxin spread in nature or in the fields, maybe more specifically?
That's a very important question, because when we know how aflatoxins move around both on the field and into individuals, then we're able to manage this much better. Aflatoxins are not contagious diseases like other diseases are. And when they infect crops, they can start the infection from the field all the way from production to consumption throughout the value chain. So aflatoxin contamination can start on the field, continue at harvest, post-harvest in storage, and in transportation, the accumulation can continue. But I would like to mention that this is especially the case when there's a high fungal pressure of the bad aspergilli on the field. So in nature, there are two types of aspergilli in this Aspergillus flavus group. There are those that do not produce aflatoxins, and this is why Aflacife is important. We'll talk about that later. And there are also those that do produce aflatoxins. So when the fungal pressure of the toxin producers is high on the field, then the chances of high accumulation of aflatoxins in the crop exist. And now with climate change, there is inconsistency with rainfall patterns, and sometimes there's rainfall during the harvest stage, there are drought conditions, there's water stress, and these pose additional risks to the crop, and the risks of aflatoxin contamination are higher. Aflatoxins can also be transmitted through pests. So when there's insect pressure, or when vectors carry the pathogens from the soil to the crop through the silk channel for crops like maize, and through cracks or insect damage, then the fungus is able to enter the crop, and accumulation of the toxin can then continue. And through the value chain, as the conditions are right, warm conditions and wet conditions after harvest, then accumulation of the toxin continues. So that's how aflatoxin contamination starts from the field and progresses through the value chain all the way to processing and consumption.
Thank you, Doctor. So it's really a very persistent disease actually, and you illustrated very well the effects on human health, but also on food and animal productivity, and so ultimately it will have a negative impact on the living income of the farmers in Africa in particular. So I want now to ask Ms. Camo, why and how can we say that aflatoxin has now become a real food security issue in Africa?
Thank you very much for that question. And indeed, earlier in your introduction, you talked about the issue of food losses because of aflatoxins. And therefore, the food contaminated by aflatoxins, and remember here we're talking about the common staples, the maize, the sorghum, the groundnuts, common staples in Africa, when they are contaminated with aflatoxins, it therefore means they're not fit for human consumption. And therefore, those foods are supposed to be destroyed. They're not even supposed to be fed to the animals. Like Dr. Titi has just said, aflatoxins also affect animals. And so aflatoxins mean that food that was produced for consumption by man or by animals is pushed out of the system. And that creates significant issues of food insecurity. Further on, it causes a lot of losses because you can imagine seeds, fertilizer, other inputs, including labor, were put in to produce that food. And then right at the end of the pipeline, it's not available because no one can consume it. So aflatoxins have been known to cause serious losses. I'll give you a case in point. In Kenya, in about the year 2014, significant amounts of maize were contaminated with aflatoxins in upper eastern Kenya. And the government mopped up that maize. And since it could not be fed to anyone, neither even animals, it had to be destroyed. So you can imagine the situation where the government is mopping up the maize. What do? You have to give those households something else to eat. You have to replace that food. Otherwise, they won't surrender the contaminated maize. So that brings in one cause that the government had to replace food for those households, then mop up this food and destroy it. The cost of destroying that contaminated maize was so high that more than the value of that maize. So net, if you put all the costs together, it cost a significant impact on resources that would have been used to provide more food to more people, going to destroy maize that have been contaminated by aflatoxins. We have also seen case in point where millers, for example, the impact on industry. Millers are buying maize, they test, it's contaminated, and they reject. You can imagine for a miller who has been involved with the farmer right from production and has mapped out in their supply chain that we expect so many tons from farmer, and it is contaminated. And this is something they get to know right at the point of delivery, while it is even scheduled for production. So that has also caused a lot of downtime for a lot of millers. They hardly have enough raw material. They have to, their rejection rate has been very high. So aflatoxins have a very big threat, and a very hidden threat to food security. And this is partly the reason why, for a lot of smallholder farmer communities, when maize is tested and they're told their grain is contaminated, what do? They hide it. They don't want to surrender it because it's the difference between sleeping hungry and having food on the table. What they don't realize is the impact of consuming that food, like Dr. Titi has said, what this means, because in very few cases is the impact of consuming contaminated foods immediate, where we are having fatal cases, death. A lot of the impact is long-term. And since that is not seen, so a lot of people don't realize that this is a serious problem. But truly it is, and a very big risk to food security.
I think you've made it very clear, Jane. Thank you for that. So building on your example of Kenyan government intervention, to deal with this aflatoxin issue on maize. What sort of regulatory and legislative measures have been introduced to limit the spread of aflatoxin contamination? Because looking at the impact of this silent killer, we feel that regulation is critical.
Indeed, you are right. Remember where we began? We said the fungus is invisible. Once the maize is contaminated, you can't tell it by just looking at it. You can't test it. You need a lab analysis. And therefore, what we have seen is the necessity for governments to regulate food standards. And one of the standards, amongst other food standards, is the aflatoxin standard, especially for grains. And so in Kenya, for example, and in the East Africa region at large, we have the East Africa grain standards, and amongst that is a stipulated standard for aflatoxin in maize, which is 10 parts per billion. We have similar standards across other countries in Africa, but there are few countries in Africa that where if they do not have national regulations, they use the Codex standards. This is very important because remember, we are dealing with something that is invisible, something that requires action from several players. So the role of government in regulating aflatoxin standards in food is very, very important to ensure that food that is put out in the marketplace is safe for the population, is safe for the animals if it's been used in the animal feed industry. And this is where collaboration, we work very closely with standard authorities across Africa and all around the world, because this is their role. It is their mandate to test and ensure conformity by all the players in the value chain, be they the farmers or the processors. Enforcement of regulation is a weak point, but of late we are seeing a lot of being done in that front, but a lot still needs to be done to strengthen the enforcement of that regulation. Surveillance, for example. In the last year or so, we've seen a lot of that happening here in Kenya, where the Kenya Bureau of Standards has gone out to the marketplace, collected samples of maize meal, collected samples of groundnut paste, collected samples of peanut butter, and analyzed it. And companies have been penalized. Products have been pulled off the shelf. They have also made a lot of, they have published all this information. And so the public now is becoming more aware of this hidden problem called aflatoxins. And it's common now to hear conversations among Kenyans, is this maize flour safe? And so when there's pressure for the consumers, this also puts pressure to the processors to begin ensuring conformity to these standards. So it's a collective effort that requires everyone pulling together, but certainly to kick it off, the government and regulatory agencies have a bigger part to play.
Absolutely, absolutely, Jane. In this collaborative effort, IITA's role was to develop a new solution to combat aflatoxin on the field at farmer level. Dr. Falade, can you tell us a bit on the history of the development of this product called Aflacife?
Let me talk about what Aflacife is. So Aflacife is a biological product with active ingredients comprising non-toxin producing strains of Aspergillus flavus. So in nature, there are naturally occurring toxin producing and non-toxin producing strains of Aspergilli. What Aflacife is a composition of non-toxin producing strains that were carefully selected from the environment following rigorous experiments to identify the best well-adapted strains to the region. So there are multiple Aflacife products for the different countries in which we have worked, and all of the strains or the active ingredients used for Aflacife development in those countries were identified from the countries in which the product is made. So I would just like to emphasize that Aflacife is composed of organisms that already exist in nature. So they are not organisms brought in from somewhere else, but they already occur naturally in the environment.
Right.
And so what Aflacife does is to adjust the population of the non-toxin producers to be higher than the population of the toxin producers. So crowd those out. But talking about the history in the development of Aflacife, this has been going on since the 90s, where Aflacife has worked, IITA has worked with partners, multiple partners from various countries, including the governments of countries like the Austrian government, Australian government, Canadian, US governments, German government. We've had a lot of support from USA, the Bill and Melinda Gates Foundation, and on the African continent, from national institutions, from PACA, the Partnership for Aflatoxin Control in Africa, from universities and governments of all the countries in which we've worked in. And through the years, we have developed the product based on a technology that started in the US around the 1980s with the USDA ARS, where they identified a strain for the control of aflatoxins in that country. But what we have done is to build on that technology and improve it, because in their case, they used one organism. In the case of Aflacife, it's composed of 4 organisms across agroecological zones within the countries where they are used. And also, we have moved from using a wet process of developing the product, which was more expensive in terms of time and resources, and also just required much more labor and energy. But now we're using a technology that is faster, well adapted within countries. So it's something that the African continent can easily adapt and use without requiring as much resources of energy and time, and it's faster and more efficient. So from the R&D side, that is how the development of Aflacife has occurred over the years.
Right, and you've explained that this was also a very complex process from a collaborative point of view. I would like to ask you, Jane, how did you manage with IITA to organize and channel these collaborative efforts towards the development of this product and towards also making it accessible and available on the market? Who were the partners and funders involved? Can you explain us a bit on this multilateral collaborative process, which is interesting?
Thank you very much for that question. IITA is a research organization, and the research work we do in our vision is to transform Africa and to reach as many smallholder farmer populations as possible throughout Africa. With a mission like that, we cannot achieve it on our own. So we rely a lot on support from partners. And we have worked with very many partners, like Dr. Titi has just said. First and foremost, we have a very well comprised team of scientists, the best that there can be, working on Aflacife. We have quite a number of pathologists based in different parts of Africa working on this product. Together with that, we partner a lot. Remember, she has mentioned that we domesticated or tailor-made or improved this product from what the USDA through the ARS had developed. So we adopted the technology and then improved it for Africa. So USDA has been a very key partner in this process. And for taking this forward, we have received a lot of financial support from USAID, the Gates Foundation, and many other partners. Also very important is to realize that as this technology takes roots, other parties interested in aflatoxins, for example, PACA, the Partnership for Aflatoxin Control in Africa, the CG Agriculture for Health and Nutrition Program, all these have come in and we have zeroed in and are working collectively together to make sure that Aflacife can be readily available in as many countries in Africa as possible. Something I'd like to add that is very important to take note is that as IITA, we do not work alone. When we enter into a country, our first point of call is the government of that country through their Ministry for Agriculture. And most importantly, we establish a connection with the national agricultural system in that country. For example, in Kenya, that would be a good partnership with CARO, the Kenya Agricultural Livestock Organization, with TARI in Tanzania, and the likes of such institutions, simply because these are the national research entities. And it is our mandate as well to build the capacity of the local scientists in this technology, to be able to support this technology and take it forward. So we have had a multiplicity of partners and are always opening our doors for more partners, because by the time we reach every point in Africa, it really requires serious partnerships. Right now, we are in about 19 or so countries, yes, 19 countries where we are developing Aflacife. So we have a long way to go. And so we are very open for collaboration with partners for the product development. Taking the product to market is a different ballgame that I'll speak about later. Thank you.
Thank you, Jane. So yes, indeed, the development process has taken some time, and we can understand the complexity of it. Now that the product is ready, Dr. Falade, can you explain us quickly, how does this product look like, and how do we use it exactly?
Thank you. That's a very good question, very important one. Aflacife works by crowding out non-toxin producing strains by using non-toxin producing strains. What it looks like, when you see it, it would look like sorghum, but actually it's sorghum coated with these strains that have been identified from the environment, coated with the 4 non-toxin producing strains. And it is applied on the field before the crop flowers, about 2 to 3 weeks before the flowering of the crop. It's broadcast on the field, and after a few days, the spores, the active ingredients coated on the sorghum, begin to grow out of the sorghum and are carried by wind and onto the crop and confer protection on the crop. It confers this protection by increasing the population, increasing the pressure of the good fungi in the environment, and crowding out the population of the bad fungi in the environment. It also establishes something known as a founder effect, meaning that the population in that environment continues to be those of the good fungi rather than the bad fungi, and so confers protection to the crop over time. So that's essentially how Aflacife works, by crowding out through something known as competitive exclusion the toxin producers, such that whenever the fungi fall, because these fungi occur naturally in the environment, we're not killing the fungi. What we're doing is increasing the population of the already existing good fungi on the field and reducing the population of the bad ones on the field, so that as the crop grows and through the development stage, there's protection from the toxin producers, and so accumulation of aflatoxins is reduced. And like you mentioned earlier, that is how the achievement of aflatoxin reduction to as much as 80 to 100% reduction occurs. It's really a balancing act that nature does by itself. All we do is to assist nature to achieve that more effectively.
Very, very interesting. Yes, in terms of innovative mode of action, and it's great to mention the exact active ingredients and the way it works on the field. Jane, as you know, UPL is also leading the development of such biosolutions, biocontrol technologies. So what role do you think can UPL play to make that Aflacife technology available for the most remote smallholder farmers in Africa now?
Thank you for that question, and thank you to note that UPL will be interested in this. But before I go into what UPL can do, I'd like to mention that as IITA, we are a research organization. And so we have done our best to put out the best of the products. And we appreciate our limitations too, that we cannot take this product to market ourselves. We don't have this capacity and the capability to make it available for every smallholder farmer out there. So we are looking out for partnerships in the different countries with especially the private sector and public sector institutions as well that are willing to come on board and work with us to make Aflacife readily available like any other input, be it seed or fertilizer, at the agro-dealer point next to the farmers. We have a proven model, and that has worked for us. We have private sector distribution partners in Nigeria, in Senegal, in Tanzania, and forging more partnerships and arrangements like those in many other countries, including Malawi, Mozambique. We have also a public sector partner in Kenya. So, and these have been models that have proven that we can get Aflacife out into the marketplace, into the farmers' hands. So what we do is technology transfer to the companies of the nature of UPL. We train you on this technology, and then we leverage your resources to increase production, scale out production, because it needs to be produced for every country, and then subsequently distributed, marketed, and made available to the smallholder farmers through the usual distribution channels for all materials. UPL and the likes of UPL, and here I talk to all the private investors, private sector especially, you are the champions for Aflacife. You can be the champions for Aflacife because understanding the impact of aflatoxins, both on the food supply chain and on the industry itself, we look forward to working with private sector partners who can also be the voice in influencing policy change. We just talked about regulation and enforcement of regulation. How do we partner with governments to strengthen their capacity to regulate and enforce regulation? We know that the likes of UPL, for example, in the area of manufacturing, you are a big entity in manufacturing, and we know we can better optimize the production process by partnering with you. As well as we are looking at opportunities for leveraging on farmer training. Aflacife is not a usual product out there. It calls for a lot of farmer training, and so leveraging on your extensive agronomy teams that can be trained and to pass on that information to the farmers, the agro dealers as well. Leveraging on your marketing teams that can help us craft the right messages to get this to the farmer. Not just to the farmer, remember, we also need to get these messages out to all the consumers. Aflatoxin should be the business of everyone. If you eat food, you should be concerned about aflatoxins. And therefore, we need to work together in the marketing department. How do we get the message out? How do we make this invisible silent killer visible? It's by communication, and communication across both the entire value chain. I also see serious partnerships with the likes of UPL in the areas of making Aflacife available and accessible to the smallholder vulnerable farmers. Let me tell you something. We have seen, studies have shown that smallholder farmers, rural smallholder farmers, are most exposed to aflatoxin. Why? Because their diets are predominantly those staples that they grow. And therefore, because they don't have a very varied diet, they are very, because they consume what they produce, if it is contaminated, they have a higher chance of being affected by the aflatoxin. And so the likes of UPL and other organizations, through your corporate social responsibility, we can partner to make, together with governments, national governments, partner to make Aflacife available to the rural vulnerable farmers who may not be able to buy Aflacife, who even may not be able to be reached by the normal channel of communication on Aflacife and how to use it. So deliberately forging into partnerships with development partners to reach those vulnerable rural farmers who are even most susceptible to the aflatoxin. Thank you.
Thank you very much, Jane, for this explanation, and we very much look forward to UPL contribution in the fight against aflatoxin and make Aflacife available for the benefit of and the health and the livelihood of smallholder farmers. On that note, we are coming to an end to our discussion and our episode today. I want to thank you very much, both of you, for being our guests today on UPL Insights and for a very insightful conversation. To find out more on UPL work on Aflacife, you can click the link in the description of this video, and you can also subscribe to this channel to follow our full podcast series for the AGRF. Thank you.